Everyone, I'm Won Lee. I tried to finish chapter 4 estimation, but I'd like to add one more lecture on t distribution. Okay, let's see. There is a t distribution table like this in statistics textbook. Okay, but if you analyze the data using a computer, the computer program will provide accurately calculated probabilities from t probability distribution function. In other words, computer program has about f of t. I told you it is very complicated thing, something like this. I don't memorize f of t, so you don't have to look at it, I think. Anyway, how to read this t distribution table? Okay, there are different degrees of freedom, 1, 2, 3, 4, 5, 6, up to infinity. And for right tail area, if right tail area, this part is 0.001, very small one, then t value is like up to here. This area is 0.005, very small, then t value will be changed like this, depending upon the degree of freedom. Let's see, 0.025. 0.025, yeah, let this part is 0.025, then degree of freedom 1, 12.706, degree of freedom 2, 4.303. Okay, as degree of freedom increases, the value gets smaller, smaller, smaller. In other words, t distribution like this, it is fat tail symmetric like this. Degree of freedom is small. The t distribution looks like this. Degree of freedom becomes larger, bigger, then it's about this way. Okay, and degree of freedom infinity is here. The value of t is 1.96. Degree of freedom is infinity. It's going to be g standard normal distribution. I told you before, this part is 0.025. The t value is 1.96. It coincides with the standard normal g. Okay, when the degrees of freedom are infinity, the t value corresponding to an area of 2.025 in the right tail is 1.96. So as the degrees of freedom for t distributed random variable t increases, degree of freedom increase, the t distribution approaches to the standard normal distribution. This shows it. Theoretically, we can prove this kind of a thing, but here we don't have to theoretical background. Okay, let's see one simple example. Suppose there are 10 data. This data is number of customers served by a particular employee, okay, at a service counter. Okay, 172, 169, 176, 170 per day is number of customers per day. Estimate the average number of customers, say mu, served by this employee in a day. X is what? Number of customers served by a special particular worker. Okay? Number of customer per day. Customers per day. So what is estimate of expectation of x, in other words, mu. It is x bar. X bar is calculated as 171.7. Okay, this is the estimate of mu. For reference, standard deviation of this data is 2.452. Oh, especially, it is assumed that the number of customers served in a day follows a normal distribution because they are only 10 data. So we cannot apply central limit theorem. So what x follows normal distribution. Okay, let's assume in this case x follows normal distribution and calculate 95% confidence level. At the 95% confidence level, find the confidence interval for mu. That is what? X bar minus t alpha over 2 times s divided by square root n. N is 10, s is 2.452, and the t value is from here, this one, okay? In this case, alpha is 0.05. So right side, right tail area 0.025. What is the difference? Degree of freedom? 9, because the number of data is 10. So we may use this value 2.262 here, and s value square root n x bar is from here 171.7, left hand side, right hand side, minus, plus. Okay, and how about at 90% confidence level? In this case, alpha equal to 0.1, right? So t alpha over 2 is 0.05. So degree of freedom is 9. The t value is 1.833. 1.833 times 2.452 over square root 10. Okay, so we can calculate the confidence interval for mu. Okay, all right. This t value, t distribution, is very important distribution in statistics, especially when you analyze the data by a computer. So I hope you may understand what t distribution is, and look at that some example like this. Okay, okay. This is a real final lecture, chapter 4, estimation. Are you comfortable with my lectures? The last chapter is testing hypothesis. Okay, that is the very fundamental principles of statistics. So I hope you are ready to follow my lecture. Okay, thank you. Bye.